Hello. Hello, welcome to another class with me. My name is Ming. Our learning target for today is how do I identify proportional relationship from a table, a graph, and an equation. All right, so we're going to get started. So over here we have two graphs. Which of these represent a proportional relationship? Well, let's look at it this way. We need to know that a proportional relationship is represented by a line, all right? So it has to be a line and passes through the origin. The origin is 0, 0, all right? So must be a line and passes through there. So A in this case is a line, but it does not passes through the origin, right? So have a look at here. It does not pass through the origin, but this one, this does. Is it a line, right? So is this a line? Yes. Does it passes through 0, 0, the origin? The answer is yes. So B represents a proportional relationship. So B, the line B represents, or line B, right? Line B represents a proportional relationship because it is a line that passes through the origin. Origin is 0, 0, for example. All right, so let us look at another example. In the second example, we have two graphs, A and B again. Which of these represents a proportional relationship? All right, let's check. Is this a line? No. Answer is no. So if it's not a line, then it is automatically is not a proportional relationship. Although in this case, it does pass through the origin, but it's not a line. So this is not a proportional relationship. Nope. The second one is a line. Yes. Does it pass through 0, 0, the origin? The answer is no. So in this case, it's also not a proportional relationship. So in this, the answer for this is none of the above. Right? Represents a proportional relationship. Right, so I hope this is easy enough. Right, next thing, we're going to look at table. So here we have three tables, table A, table B, and table C. So what do we do? Well, first of all, just like in line, does it passes through, does it have, so question is, does the table, does it contains 0, 0? Right? First thing, if it's yes, then it is great. Next, right? Are all the entries are equivalent ratio? If it's yes, then if both of these are yes, then we have proportional relationship. So if both of these are yes, then we have proportional relationship. So the first one, does it contain 0, 0? Yes. Next, we're going to check, all right? The ratio, the first one is going to be 100 to 14.5. So you can write it as a fraction, 100 over 14.5. And the next one is 200. Can that be obtained using this? The answer is yes. If I multiply by 2 and multiply by 2, then I will get 200 over 29. That's great. How about 100 over 14.5 times 4? If I times 4 on both in the numerator and denominator, then I get 400 over 29 times 29 plus 29, that is 58. So then is again okay. Now how about the last one? 100 over 14.5 times 8 in the numerator and also in the denominator. So that will give me 800. And then 58 plus 58 is 116. This is perfect. This is a proportional relationship. So A represent proportional relationship. How about B? B, now we have a problem. How about, does it have 0, 0? The answer is no. So if this is no, then it is unlikely this is going to be proportional relationship. So the answer to this is no. And then also, although the equivalence ratio later on, right, 2 over 40, for example, is 1 out of 20, and 1 out of 20 times 4 give me 4 over 80, which is the second ratio. That's great. 1 out of 20 times 6 in the numerator and also times 6 in the denominator give me 6 over 120. That's great. But unfortunately, it does not pass through the 0, 0. So this is not a proportional relationship. Then the last one. The last one, first of all, does it passes through 0, 0? Again, the answer is no. And then how about the ratio? So 1 over 2, is it equal to 2 over 3? Well, the answer in this case is no. Right. And then how about, well, 3 over 6 is half. That's true. But again, 4 over 10 is not equal to half. Therefore, in this case, this is not a proportional relationship. Right. Last thing that we have to do is look at equations. So now we have 4 equations. Which of these represent a proportional relationship? Very good. So this y equal to x plus 1 is not going to make it because, right, if I put in 0, if x equal to 0, then y is equal to 0 plus 1. So you can see that here it does not include the origin 0, 0. So B is definitely not a proportional relationship. How about C? C, although if we put x equal to 0 in it, then what you get is y equal to 0 squared, which is 0 again. So C passes through the origin. Passes through 0, 0, which is good. But is it linear? Well, unfortunately, this is not linear because if I look at the ratio, how about y equal to x equal to 1? Well, if x equal to 1, y equal to 1. And how about, because 1 squared equal to 1, how about x equal to 2? When x equal to 2, y is equal to 2 squared, which is 4. And now you look at the ratio. 1 over 1 is not the same as 2 over 4. Therefore, this is also not a proportional relationship. Now, which of these are proportional relationship? A and B. You can confirm that both of these, right? Both of these contain 0. For example, y equal to 0.025 times 0. That means give you 0, right? So 0, 0 is contained in A, and 0, 0 is also contained in D because 267 times 0 is also 0. So both A and D contain 0. And then later on, you can see that from this equation, if I simply do y over x, then y over x is always going to be 0.025, regardless of what I'm using. So this is constant gradient. And for A, for D, this is for A, and for D, I have y over x is always 267. So the ratio are always going to be constant. So in this case, I have a proportional relationship. In fact, anything of the form y equal to mx is a proportional relationship.